All right, let's do practice problem 4 on page 122 in chapter 6. Here's the problem. It says the 225 Newton force is exerted on the crate toward the north, and the 165 Newton force is exerted toward the east. Find the magnitude and direction of the net force. So given, here we've got some kind of crate right here. Maybe we're looking down on it from the ground. Here's north, south, east, west. And it says it's got a 225 Newton is exerted on the crate toward the north. So here, I'll call this F1. And I just made that up. You didn't have to call it F1. But 225 Newtons. And then F2, it said the other force is 165 Newton force is exerted toward the east. What did it say? 165. And it wants to know what is the net force. Ooh, let's do find. The net force. Well, so let's solve it. So the net force is just what you get when you sum all the forces acting on the object. And these are the only two forces given. There might be a force of friction, or not force of friction. There might be force of gravity and a normal force and all that, but we're looking down on it. These are the only two forces they gave us. So we're just going to assume these are the only two forces acting on the object. So the net force is what we get when we add these forces together, but these forces are vectors. So we have to use the vector addition that we learned in the last unit. So F net is equal to, well, it's going to be F1 plus F2. Now F1, we can put these in rectangular coordinates right away, right? What is F1 in rectangular coordinates? Look at F1. How much in the X? How much in the Y? Newtons. And then F2 is 165 newtons and 0. So the net force is what you get when you add those together. So I get 165 newtons in the X direction and 225 newtons in the Y direction. Now let's, it said they wanted the magnitude and direction, so that they want this in polar coordinates. So now I could just say, well, the net force is the square root of the X component of the net force squared plus the Y component squared. So let's do this. So 165 squared plus 225 squared. See, that equals, and then take the square root of that. And I get 279 newtons. Now let's figure out what the angle is. It's the inverse tangent of the Y value over the X value. Don't need to add 180. Well, I can put plus 180 degrees, but then I check my X value. Oh, it's positive. Don't need to do that. So theta is going to be equal to, let's see, 225 divided by 165 equals, and then I'm going to go inverse tangent of that. And I get 53.7. So the net force on this object is just, oops, off screen. The net force is 279 newtons at an angle of 53.7 degrees. And that's going to be, or you can say 57.3 north of east. But that's kind of redundant because we're going to leave this in polar coordinates. So, of course, that means north of east. Okay. Any questions? So the net force is what you get. Have you seen this summation sign before in your math classes? Okay, some of you have, some of you haven't. You know, we use abbreviations in math because it's just faster, right? I don't want to say add up all the forces. Well, this means add up all the ... and then the F means forces. So you add up all the forces. That's what the sigma symbol means when we use it in this class. We're going to add up all the forces to find the net force. That is all.